Next up, we have Orbital Spaceflight and Beyond. It'll be a similar structure to the suborbital spaceflight panel you just saw. Question submission will be exactly the same. And we should have the information up on the slides now for the website and the text number. So for decades, orbital spaceflight has long been restricted to only the wealthiest government space programs. What can be done to support, what can be done to support commercial orbital companies, and what are companies doing to open up Earth orbit for commercial applications? Today's moderator will be Dennis Stone, who is the manager of project integration of the commercial crew and cargo program at NASA. So Dennis, it's all you.
Well, welcome. It's great to see you all here. This is really the place for commercial space, the NewSpace conference, and I want to congratulate the Space Frontier Foundation for another great event, and for all of you for being here. It's an honor to chair today's panel on the orbital spaceflight. You just heard about suborbital. Well, we're going to take you to the next step, and by the time you're done on Saturday, you'll be way out there, right? So as Lori Garver said today in her keynote, orbital space transportation is really the key to not only commercial space, but even to NASA. And so we're really glad to see this panel here today. I work on the COTS program, the Commercial Orbital Transportation Services, and we're focused on cargo. And you know about SpaceX and Orbital Sciences are our two partners. SpaceX is represented here today, and soon, right, they'll be flying to the space station carrying cargo, and the next logical step beyond that is to carry crew, and so we'll be talking about that as well today. And with cargo and crew, we see those services as being the key to opening up not only NASA's full use of the Great International Space Station. Now it's fully assembled and ready to serve a vast array of science and other markets, but also to open up other uses of low Earth orbit. Some we are talking about, and some we have yet to even envision. So it's I think a good area for the government to be investing its capabilities, technology, and financial resources. Classic case of dual use. We've got something to benefit in both realms. So today we want to talk about what's going on to open up LEO, particularly from a transportation sense, to serve both government and private sector companies. So we have a great panel here today. I'm just going to briefly introduce them. Starting on your left, we have Jake Szatkowski, who's the SmallSat program manager for the United Launch Alliance. We have Garrett Reisman, who's an astronaut and head of astronaut safety and mission assurance for SpaceX. Then we have Brent, Jett, also an astronaut, now the deputy manager of the commercial crew program of NASA, based at the Johnson Space Center, where I work too, as a matter of fact. And last but not least, we have Mark Sirangelo, who's the chairman of the Sierra Nevada Space Systems, one of our CCDev 1 and 2 partners. So we've got a great panel here today, and the format, we're going to let each one give a few minutes of introductory remarks, and then we'll have questions. So let's start with I'd like to start with Brent as the Deputy Manager of Commercial Crew. We think he'd be a good way to get us all started. And you can speak from here or there, whatever you're most comfortable.
Thank you, Dennis. I'll try to keep my remarks fairly short. I was a last-minute substitution for Maria Kalura, who's Ed's director at KSC for Commercial Crew Program. Those of you know Maria or have seen a picture of her, I'm sure, are greatly disappointed that she's not here. So Ed asked me to come, and for those of you who watched the program forum that we had last week, there's no way Ed was going to come here. So as the deputy, he asked me to come, because I know there's a lot of angst in the community about the direction of the Commercial Crew Program and where we're going with our next phase and specifically what instrument we're going to use as we proceed after CCDEV2. The whole purpose of the forum we had last week was to get input from industry, and we heard some very loud and clear, and we've been assimilating that input, and that deadline for the final comments is coming up, and that will be the end of next week. So I'd like to say a few comments about that. I heard the question to Lori this morning, and I thought she answered it very well, and asking you to continue to hold the program's feet to the fire and hold NASA's feet to the fire, that we honor our commitment to the commercial community. And that commitment, we have been very steadfast in our attributes that we will ensure we maintain in whatever instrument we use going forward. As the program, I kind of feel like I'm in DC, because there's a group of people out there who strongly feel that Space Act agreements is the only way to do it. It's the only way a program can be successful. There's another group of people out there, not in this room, but within the government and within NASA, who strongly believe to ensure crew safety that a cost-plus contract is the only way to do it. So it's almost like the debate in Washington over the debt ceiling. You know, I got to raise taxes. Well, you know, one side says I've got to raise taxes, and the other one says I got to do it all with cuts, and nobody wants to meet in the middle. So it is a difficult problem, and then we have the legal community telling us what we can and can't do in various instruments. And you know, I don't want to turn this into a legal discussion or a debate, but I can tell you that the program is dedicated to maintaining some fundamental principles in whatever we do, and that is milestone-based payments. You know, fixed investments. We're not going to require cost accounting standards to be requirements to be imposed on the partner through the instrument. We're going to minimize the overhead. We're going to do everything we can to maintain that list, to maintain those attributes all the way through the program until we reach a certified capability to go to low Earth orbit. So as the questions come up and you want to talk some more about that, I'd be happy to address those. But in my experience, it's not, whether we are successful as a program, it isn't dependent on what instrument we pick. We can be successful in a contract, we can be successful in a Space Act agreement, assuming we can do all the different things that we need to do. The question of being successful is, how do we control requirements? How do we control costs? How do we maintain, allow industry to have the flexibility to be innovative, to bring us to do things differently, to bring us solutions that are both cost-effective, reliable, and safe. If we can do those things going forward, then we can be successful in whatever instrument we pick for the remaining phases of commercial crew development. What we really need is money and support from Congress and the executive branch. We know we have it in the executive branch. Congress, depending on who you talk to, seems to either like us or not like commercial crew, and how much money they're willing to invest in commercial crew will really be a driver in how quickly we can make this capability a reality. When I looked at the House markup bill that came, and I looked at how much money was they at least proposed giving to MPCV and SLS, and then I looked at how much money they proposed spending on commercial crew next year, and it was about, if you added up the two, SLS and MPCV, and looked at commercial crew, it was about 1/10. You know, commercial crew was going to get 1/10 of the money that the other two programs were going to get. I can tell you that if that number holds for the next year, it's going to be very challenging for us to maintain multiple partners, to maintain the type of progress that we've made, and meet a goal of flying folks in the mid part of the decade. At some point, we're going to have to spend more than a couple $100 million a year in this program to get to a capability. So from my perspective, it's not really the debate about the instrument. I know is important to you all. I hope to alleviate some of those concerns and let you know that you know, we're going to find the right instrument. It's going to meet your needs. It's going to meet NASA's needs. But we really need to get support from the public and from the Congress so we can fund this program to fly as quickly as some of our partners want to fly. they want to, and when you listen to Mark and Garrett and some of the partners we have in CCDev2, they have plans to fly much quicker than we can fund them to fly. So, you know, our NASA and our funding stream is essentially becoming the limiting factor on how quickly we can return a U.S. capability to fly astronauts to the station. So I know you all are out there trying to help us in that regard, and on behalf of the program, I really appreciate all that you do to help make this program successful. Thank you.
I think now we'll hear from our industry partners, and I'd like to start with SpaceX. They've been our partner for the longest. We started with them in, I guess it was 2006 on the COTS program, and we've had a very successful relationship with SpaceX, and of course now they're also a partner with in Brent's office with on CCDev2. So let's bring up Garrett, please. Thanks.
Thank you. I got brought some friends from in the audience to kind of make me feel better. Thank you. It's really nice to be here at NewSpace and talk to you a little bit about SpaceX. I'd like to start off with a little personal observation, which is I was present at the launch of Atlantis for STS-135. And what we heard a lot in the news, if you read all the op-ed pieces and what you hear talking to a lot of people down on the Florida Space Coast area, was a lot of doom and gloom, that this is the end of America's spacefaring, human spacefaring experiment, that our best days are behind us and we're rolling our best equipment into museums. And it was very depressing, all right? I don't personally believe that. I believe that we were on the cusp of a golden age of industry-led innovation, that's something akin to the golden age in aviation that occurred between World War I and World War II, where industry really led the way, doing some very innovative things and advancing the technology and really developing a whole infrastructure to support what eventually would become the airline industry that we have today. However, as I watched Atlantis take off, I was actually struck by a couple of things. It was more emotional than I expected it was going to be when I was standing there. As I watched that magnificent launch, I thought, you know, if we fail with this commercial crew program, then all this doom and gloom is going to be true, okay? So that put the two things I felt were sorrow at seeing the end of an era, at the same time a tremendous amount of responsibility that we have to find a way to make this work. Because the alternative is incredibly gloomy, that this country will no longer be a human spacefaring country. And you heard Brent talk about a couple of threats to our success in the commercial crew arena. And these are the things that keep me up at night, worrying about you know how we can possibly succeed if the funding is cut way down. I mean, if you look at that 312 figure, that's less than 2% of the total NASA budget. So for all those politicians that were slamming their fists saying not having the ability to send Americans into space on our own rockets is a horrible thing, well, how about giving us a little more than 2% of the total NASA budget? And when you run that as a percent of the total federal budget, I can't even tell you that number. There are too many zeros behind the decimal point for me to keep that in my head. So, so that is something scary. The other thing that's scary is we do have to find a way to make sure everybody's needs are met on a contracting mechanism that Brent pointed out. You know, I think they're doing something very admirable. They know what our concerns are, and they are trying very, very hard to take the FAR and strip out all the things we're worried about. Our point that we try to make with Ed is that this is something that people have tried before and have failed. It's a very, very admirable and innovative thing that they're trying to do from a legal perspective and getting this done. We think that starting with a commercial FAR contract and adding things in you want might be a better way to go than starting with a FAR 35 type contract and trying to cut out all the unintended consequences that are in there. But I'm confident, given the fact that we're communicating and we know what our concerns are and what the pitfalls are, that we'll find a way forward, because we have to. We have to find a way forward there. We have to find a way forward with our government to provide funding. But we can do this. We have the technology, to quote an old TV show. We have, I'd like to talk to you a little bit about SpaceX, which I just joined about 5 months ago. And SpaceX was founded in 2002 with the singular purpose of advancing the cause of human spaceflight. And so that has been on our mind from the very day we bent the first metal to make the first rocket. And SpaceX, the impression I want to dispel is that it's just a couple of us in a garage somewhere cobbling together some rockets, kind of as a hobby. That is not the case. When I first came to SpaceX, when I was still an astronaut and I started looking around, I was blown away by the capability that exists in this company. We have this 500,000 square foot facility in Hawthorne where we have a rocket factory. We believe strongly in vertical integration. If you come down and visit us, you'll see metal come in, rockets go out. And it is an amazing thing. You'll see up to 3 Falcon 9s in various states of assembly sitting there on the floor, and 2 or 3 Dragons as well sitting there going through the production line. We're ramping up to meet the manifest. We've got another Falcon 9 right now sitting in a hangar in Florida. We got other engines being developed on the test stand in Texas, where we have a 600-acre facility for rocket testing. So there's a lot of there. There's a lot more meat to SpaceX than you might think. When I joined, we had 1,200 employees. Over the past 5 months, we're up to now 1,400, as far as 1,430. A little over 1,400. That includes the interns? Okay, 1,400. 1,400 employees, so we're growing fairly exponentially, and we have a lot on our plate. But it's the SpaceX. If you come visit us, I like to describe it as an engineer's paradise, because you could come in, you will be loaded up as a young engineer with tremendous amount of responsibility. You will work for some of the most incredibly experienced people in the industry. Our vice presidents don't spend their time working on financial matters or tinkering with metrics to help the stock price. Our vice presidents are purely technical. They are graybeards that have seen it all, been through all the NASA and DoD programs, know what they're doing, and they're leading this incredibly energetic young staff of engineers, and they are having the time of their lives designing rockets. So it's a real fun place to be. I'm very glad that I'm there. And my job is slightly different than the introduction. My job changed actually on my first day. Elon said, hey, would you mind running the CC Dev 2 program, which we called Dragon Rider, because we thought it sounded better. No offense. No offense. So that's my job, is project manager for CC Dev 2. And what we're doing is we're taking our Falcon 9 rocket and the Dragon capsule, both of which have already flown. The Dragon orbited the Earth last December 2 times, splashed down the Pacific. We became the first private company to bring something back from space. And that led to a really big party. That was very exciting. But anyway, we're ready now to take that next step, and we're looking at what we need to do to add in to the Dragon capsule and the Falcon 9 for people, things that cargo don't need, things like suits and seats and breathing, environmental controls and life support, and most importantly, the launch abort system. So that's really the focus right now, is developing that launch abort system. We just had our first major launch abort system milestone, a conceptual design review 2 days ago in Hawthorne, and we got that milestone approved, and are progressing now. In September, we'll have the PDR, and very soon you're going to see out in Texas a new test stand and fire coming out of our Super Dracos, which are our launch abort engines. And I got a little video I'd like to show, and then I'll pass on the mic to the next guy.
If there had been people sitting in the Dragon capsule today, they would have had a very nice ride. only one major development item, and that is the launch escape system. We're going to build the escape entrance into the sidewall of the spacecraft. We'll actually be able to have escape capability all the way to orbit. Even the Apollo didn't have that. Also, because you don't have to release the escape tower every time, you don't have that as a necessary thing that has to occur with every flight. Capability is the very reason SpaceX was founded. So we will do whatever we need to do to make this happen.
And by the way, we're going to be taking written questions, or you could submit them through various means. So think of your questions now and get them turned in. Our next speaker is Mark Sirangelo. Mark has been a key part of this for many years. His company turned in some very strong proposals on COTS. Finally, they won a very nice award on CCDev 1. They went on to continue on CCDev 2. Congratulations for that. They have a very innovative entrant into the commercial space transportation arena. So please welcome Mark Sirangelo.
Thank you, Dennis. I have the privilege of being able to speak later this afternoon for an extended time, so I'm not going to repeat myself twice and give us some time to have some questions. But our company is really privileged to be part of this whole commercial crew program and really going to orbit. We've been at this now for about 7 years. Our program is called the Dreamchaser. It's a lifting body runway lander. It's a very unique design that has its basis in NASA, and we like to say actually it was born at NASA a long time ago as a program called the HL-20. And I'll, hopefully you all will be here, and I'll be standing between you and the happy hour later this afternoon, so I'll keep my comments to speaking to later. But I did want to make a few remarks right now because I think it is important. And as an entrepreneur, as someone who's been around this industry for a long time and building companies up, we have now almost 2,200 people in our company around the United States. We have a good sense of how to run a business and grow one. You don't do that if you're not optimistic and if you don't have a positive outlook about the future. And so much of what we hear these days is about negative attitudes and where we're going. And I spend a lot of time talking about what's good in our industry and what's good in our country. And even when people see things negatively, we try to look at it and say there's some pretty good things in it. And probably one of the most challenging things that we've heard was the report that came out of the House regarding how much money was put aside. And many people saw that as being a statement. I actually saw that as a pretty good thing. And I know we can be a little bit bizarre in our world and sometimes see things from a different perspective. But let me tell you a little bit of a story behind that, because I've spent a lot of time in Washington. Last year, that same group of people looked at this same program and said, we don't think it should exist. We think it should have a zero budget. We don't think that there should be a program. And one can look at this and say, well, maybe it's not all the money we need, and it's certainly not. I looked at it and said, well, all of a sudden we had a group of people who were perhaps one of the more negatives on the future of commercial crew, now not only saying that they think on the record that the program should exist and that it should be there, but they're providing, in their view, funding to make that happen. And instead of having a floor of zero and a high of the president's budget of $850, we now have a floor in my mind of $300 and some odd million and a president's budget at eight something. And to me, that makes a statement. It makes a statement that there are changing views. People are looking at things differently. Perhaps it doesn't move as fast as we want it to, but I believe that we will get there. I was also at the last shuttle launch, and you feel the feeling when you're in Florida. But you also feel that there are people, many people in my view, who want to see what's happening next. And we get so much excitement around our program, and I'm sure the other companies' programs. And it's building. There is a momentum. And I guess the message here from me to you all is that while things always tend to look darkest before the dawn, there is a dawn coming here, and we are moving forward. We're going to be flying next year in our vehicle. And I'll show you that later this day, and you'll see some pretty unique first-time video that we haven't really shown out in the public like this before. And we wanted to give an impression that this is not something that's on paper. All the companies are working hard. We're passing our milestones. We just finished our 3rd milestone on the CCDev2 program ahead of schedule. And there's a lot of momentum building here. And there are a lot of people talking about things like contracting method, as Brent said. And my view is that those things will be resolved. We're here to fly. We're not here to generate a few contracts and some money. We want to go to space, and we're going to go to space. And I'm going to go to space, and I hope a lot of you will come with me. And that's what really matters at the end of the day. NASA is our partner, and I feel that we're privileged, and sometimes we forget that. We've been given money to go do something, and that money is the taxpayers' money. And in my view, that means that we stand up and we support the people who are working with us, in this case NASA, and we support the taxpayers who are trying to work with us by being reasonable. We have a partnership, and partnership means that you need to sit down and understand both needs. And in my view, the contracting mechanisms will get resolved, and we'll work through that. The bigger issue is making sure we have the proper funding for this program and making sure that all of us meet our milestones and go forward. That's the fastest way to make this happen. The rest of it will be fine, and we'll make it and go through. So I wanted to thank you all. I've been speaking at this for a number of years, and I love the way that it's been growing and getting more and more attention. It's a terrific opportunity for us to talk. We're part of the new space industry, and I look forward to giving you a real good view on our company and what we're doing later this afternoon. Thank you.
Our last speaker is Jake Szatkowski of United Launch Alliance. They are a big player in this, even though they don't have a funded agreement with us right now. They were a funded partner on CCDev1, and they are an unfunded partner on CCDev2. Their launch vehicles will be used by some of our other partners, so they are a very important player in the ecosystem. Here to tell us more is Jake Szatkowski.
Well, thank you. Yeah, I'm from United Launch Alliance. It's a formulation of our friends from Lockheed and Boeing. It's kind of like being the daughter of 2 divorced parents. But the CCDev activities that we've been supporting, we are unfunded. It's a joint master agreement that we are working with our NASA counterparts to provide launch service. That's what we do, is provide launch services. The joint master agreement that we have between Lockheed and Boeing causes us to provide that kind of service to any comer. So hence you see a number of different companies that want to fly on us. How can we make that happen? We need to be able to man rate the Atlas and Delta launch vehicles. We've actually been working on that kind of technologies for some time. I did some initial studies back 15 years ago, so it's been kicking around for a long time. We don't see it as a great technology problem. It's pretty much good old-fashioned engineering, and that's we did such a good job of saying that it was easy that we didn't get funded. So, but that's okay. We are funding it internally to provide that launch service. What I am going to give you a little bit more about is how can we provide launch service to y'all as far as easy access to space, whether you want to go to LEO kind of space, low Earth orbit kind of activities, or more exploration kind of stuff that would be like the Lunar X Prize kind of things. So I have a couple of slides. We're going to flip through them real quick. If you want copies, I can easily provide them to you if you give me a card or something, and I brought some with me. So let's flip through these real quick. This one just shows some of the history of our rideshare missions that we've been doing recently. As you see, the LOO, L-Cross mission was the last one that we did. Very successful program. It was a very fast-paced system approach, marrying two different payloads together to go off to the moon. But we've done a number of them over the years. Next chart. This is some of the rideshare concepts. What is rideshare? Basically, you're sharing the cost. Oftentimes, if it's a government payload, the government's already paying for the rocket, so you're paying for the integration costs. If it's a commercial mission, like we're signing a contract today for commercial rides, we are going to be providing opportunities for people to have fairly low-cost access on ride shares for commercial missions. And we have a number of them coming up. Next slide. This just gives you, I'm sorry, it's an eye chart, all of the different types of ride share projects that we've been working on. Different kinds of capabilities, sizes, payload masses, everything from P-pods all the way up to Delta II class payloads. With our DSS 4 meter and DSS 5 meter, we can lift up to 5,000 pounds. We consider that rideshare for second payloads. Next chart. This is an adapter platform that we have for rideshare that can take equipment up for TRL level improvements that can ride alongside of the Centaur upper stage. Next slide. This is an aft bulkhead carrier, the orange box, kind of funny shaped box in the bottom corner there. That is going to be flying on L-36 next year. It's a 170-pound capability. And it's let off of the back of the Centaur, which means you're not in close proximity to the primary payload. That allows you to potentially get off early if you want. Next one. This is something that we've been working on for some time, integrated payload carrier. We're using the internal volume of these, what we call C-rings, in a mix and match form so we can create vertical volume with a diameter up to 60 inches, but you can put a number of payloads inside there. You can match it up with an ESPA ring for secondaries on the outsides. But using that internal volume allows us to carry spacecraft up on a center line of the launch vehicle. And once the primary is gone, you have a clear shot at getting deployed out of there. We've looked at payloads up to 7 feet high for that kind of a carrier, and like I said, we just signed a commercial agreement to put one of these up in 2013. Next slide. Of course, the ESPA class payloads, 400-pounders, 6 of them. We've launched STP-1 very successfully with 3 orbital plane changes. And we will be doing a separating ESPA, flyaway ESPA on DSX here in another year and a half or so. Next slide. This one is the ability to deliver payloads other than where we typically go. We typically go to geosynchronous orbit or geotransfer orbit, or we'll do a polar sun-sync kind of an orbit. But if you want to go to a different altitude, sometimes it's more difficult for us to do. So this third stage capability will allow us to deliver ESPA-class payloads to different places other than those typical kind of orbits. Well, this will also be able to do Earth escape missions for like lunar type missions. Next slide. This is our DSS 4 meter. Again, it's 10,000 pounds upper, 5,000 pounds lower. Fits inside of a 4 meter fairing, 10-foot diameter. And this one is being offered on a NASA mission here shortly, as soon as we get all the details ironed out. But so this will be flying in about 2 years. Next one. This is a 5 meter, DSS 5 meter. It will have the capability of launching 2 GPS-3 satellites to orbit. And the last slide, no, one more. This is our external payload carrier. For suborbital missions, if you want to do suborbital, it's like a solid rocket motor, but empty. It will go to 900,000 feet so basically 180 miles up. It will carry about 3,500 pounds. It's 60 inches in diameter, 70 feet long, so think of a semi-truck going to suborbit. It'll give you 6 minutes of zero-G. Next slide. This just tells you all of the missions that we have coming up, the kind of payloads that could fly on those things as rideshares. Next slide. And then this just shows you the spectrum of things that we have available that we've been working on. Many of these things start out as IRAD. A lot of them have transitioned to first flight, real program activities, and all of them are on the docket for missions. Thank you.
So now's the part of these I like best, and that's where I get to start asking questions of our panelists, and then we'll open it up for interaction and questions from the audience. But I only have one, so don't get too concerned, but it's a pithy one, though. Lori mentioned today that, in her view, space is just not for government. Obviously, I think you all feel the same way. We're here to talk about commercial space. But yet, on the COTS program and commercial crew, government is the primary investor, government is the primary customer. But yet, we want these to be commercial. Lori mentioned anchor tenancy as a key way. You know, you build a mall, you sign up the big department store, but you want these other guys. And Jake just talked about one model for bringing in some of the smaller customers. So my question is, how do we affect the transition to a more commercial base for low Earth orbit in the programs we have today on COTS and commercial crew? Does it affect our procurement method? Does it affect our requirements, our insight, our oversight methods? Are there things the government can do to open other markets? What are we planning to do? What should we be planning to do to keep commercial cargo and commercial crew truly commercial? So why don't we just go in order? Jake, you want to be first?
Well, I guess the first thing that comes to mind is when we think of technology to support these kinds of missions, I think of non-recurring costs. We need to retire those non-recurring development costs, and then we can get to true recurring costs. So that, at least in my world, rideshares kind of stuff, getting that recurring cost out of the way, the government has been very helpful. And transitioning on to commercial activities beyond that, being able to provide payloads that are already contained so that our costs are minimized is probably the best way that we can get our costs down.
I think, as you pointed out, what we have right now really is a public-private partnership, and it's actually working really well. It's working really well on COTS and very soon on CRS, and it's working well on CCDIV too. What it means is, NASA is the anchor tenant. It's the Nordstroms that you build your mall around or whatever, and that's true, and it's a source of funding, and that's true. But it's also a source, one thing I think you didn't mention was, it's a source of expertise, and that's a tremendous benefit to us. We could go ahead and Google and get all kinds of great information about what's necessary to build a rocket, at least stuff that's not ITAR controlled. And that's great, but there's no substitute for being able to pick the brains of the guys that have done it before, been there, done that. And so when we have the opportunity in these partnerships to go down and sit with our NASA counterparts and benefit from all that experience, all those lessons learned, both what to do and what not to do, it can really accelerate our efforts. And so I'm pleased with how it's working so far, and I think we just need to continue the successful model that we've had with COTS and CRS. With COTS, we've already flown C1, the first demonstration flight. November 30th, it's out there right now, it's been published as of last week, I think, is our launch date for C2, C3, so the next flight of the Dragon on Falcon 9, where we're going to take the Dragon, go all the way, and berth it to the station, drop cargo off, and bring stuff back. And that's really going to be the heralding, and the very next flight after that is operational capability, CRS-1. So this is happening. It's been successful. We're able to do it very cost effectively, given the models that we have right now. And for example, you know, SpaceX to date has up till, well, at least up through 2010, from its creation in 2002, it spent $800 million total on everything. And for that, you got the production facility in Hawthorne, the launch pad at the Cape, the launch pad that we're working on in Vandenberg, the launch pad in Quaj, the rocket testing facility in McGregor, the Falcon 9 and the Dragon, all for $800 million. And so, I mean, you know, I would like to have $800 million. It's not a small amount of change, but if you run traditional cost modeling and see what that would have cost if we did business as usual, it's a lot more. I mean, just for the Falcon 9, it was in about $4 billion, I think was the estimate. So we have a system that's working. We have something that's working really, really great. What we have to do when we talk about putting people on board, we know we have to tighten up some of the oversight, insight. We know that there's more we have to do, but we don't want to throw out the baby with the bathwater, if you will, and we want to build on the success that we've had to date.
I think Garrett said it very well. There are a couple other aspects, of maybe a little bit different way of viewing some of the points that he brought up. Having the government expertise available to provide help to our partners is key, but that really fundamentally goes back to how does the government and how does NASA approach the development of this system. And in order to enable and to be commercial, I think it's key that NASA sets our requirements at a particular level and then doesn't drive the design only to meet NASA's needs. In a traditional program, NASA will delve very deeply into levels of requirements and how the system is built and designed to a very great level of detail. What we need to do in the Commercial Crew Program is establish our needs through a set of requirements and then allow our partners to have the flexibility to build their system not only to meet our needs, but also to meet a potential commercial market. So I think that's a key difference in how we enable those markets in the future. The other things that have been mentioned, anchor tenant, obviously are very important. I think the other thing that an advantage of this private-public partnership is the fact that by NASA's involvement, I think it will help just that brand name, if you want to call it that, or the fact that NASA is willing to put its astronauts on a system and fly them into space, I think will be helpful to the commercial market in order to attract customers to go to either to other destinations. And that's the final thing is, where are the other destinations in low Earth orbit? Where are we going to go? Where are the commercial destinations? Obviously, Bigelow Aerospace is talking about a commercial space station. There is some attraction to just orbiting the Earth, and spending some time looking out the window and being in low Earth orbit. But I think ultimately there has to be destinations, and if there can be private-public partnerships in destinations in low Earth orbit, I think that's critical, because not only can we have markets that are within the United States, but I think there's potentially huge international markets available for a real destination that offers the ability to do research that helps meet the needs of most administrations that we have had that want to encourage science, technology, be motivational to education. So I look at that as sort of, once we achieve the commercial capability to get to low Earth orbit, maybe the next step are those public-private partnerships for destinations in low Earth orbit.
I fully agree with that. Actually, I'll take it a little bit further, because we talk a lot about destinations, and in our company's plan for the future, it's not just destinations, it's also missions. The approach that we're taking with our vehicle is utility. We can take cargo and critical cargo and crew to the space station and return it, and that's a big mission for all of us. But that's not the only mission. We heard earlier a little bit about having 6 or 8 minutes or 10 minutes of suborbital time, and that's terrific for science. What about having 6 weeks of orbital time on a vehicle? What would that do for science? So our view, we have multiple markets. We're looking at being an orbital test bed. We believe that we can provide transportation to other destinations, as Brent has talked about. But beyond that, we also see that there are capabilities to do potential servicing missions in low Earth orbit. With the shuttle going away, there is really no significant way to do that right now. As we look at it, and I encourage other people to look at it, that it's not just about moving people back and forth to the space station. It's about building a system of being able to do multiple things in LEO and do those in a cost-effective enough manner that it actually opens the door for people to want to do that kind of work.
Very good. Well, let's start with some questions that have been coming in. Of course, commercial crew flights will be carrying NASA astronauts to the space station, but there will also potentially be these other flights, or maybe non-NASA astronauts on those flights. I don't know. But regardless, what are the plans for training and recruiting and training commercial astronauts? So let me do SpaceX in Sierra Nevada.
My boss at SpaceX was my boss at NASA. He was, Ken Bowersox. And
Oh, okay.
so I know
Right.
at the best I can be is number 2 in line for flying as a SpaceX astronaut. But the thing is that really we haven't crossed that bridge, and what we're focused on right now is taking NASA astronauts to the space station. So when we do our first test flights, assuming it's under a follow-on program, the CCDEV-2, we will have to work out who that test crew is going to be and who's going to consist of. Is it going to be SpaceX astronauts that fly those tests? Is it going to be NASA astronauts that fly those tests? Or is it going to be some combination, some kind of joint test team? All those, that trade space is completely open. We haven't decided that by any means, and we'll be working with NASA and figuring out what's the most appropriate way to proceed. And as far as the model, there's been a lot made about this taxi versus rental car model. In other words, the taxi model being that a SpaceX pilot brings up the NASA astronauts to the space station, drops them off, comes home. The rental cars, the NASA astronauts take it themselves and fly. It's not important to us. We will provide whatever capability and ops concept in that regard that our customer wishes. So those things are all still very much TBD, and we've given some thought about training, what would be required for training of the crew, but again, we're still that's still a few years away.
Mark?
I mainly agree with what he said, but one thing that I would add is that we see that there are multiple models for how things can go in space, and one of the models that we think is also viable beyond the taxi cabin, as we mentioned, is taking a page out of the maritime industry. When you look at how ships are moved around the world, if one is moving a large tanker ship, that it is the captain and the owners of those ships that move that ship around in open waters, but then there is a harbor pilot that comes out who knows the particular area around the harbor. And one of the views that we have is that the combination or blending of NASA personnel and commercial personnel in doing things perhaps like our commercial astronauts taking the flight off and bringing it to orbit, but the NASA personnel doing the docking maneuvers or doing the proximity operations around station, which they've been well trained for over many years. And it's the same kind of approach that's used in the maritime industry, where the ships are then brought into the harbor by somebody who actually knows it pretty well. That does two things for us. It allows us to continue to work with NASA in a very blended way, but it also allows all that investment that's been made in the astronaut corps to continue to be relevant.
Thank you, Mark. All right, so this is one of those touchy questions. Can the industry participants, I guess it lets you off the hook, Brent, explain what is the extra paperwork burden or other problems about doing future CCDEV or commercial crew work under a FAR-like contract as opposed to a Space Act agreement? Anyone want to jump in on
I'll try that, and then you guys can clean me up and see what I screwed up. Yes. Frankly, from our company's perspective, we don't really have a concern one way or the other. We think that the Space Act agreements have been very productive, but we have many dozens of FAR contracts every year. We know how to work it. Where it becomes unclear and different is, I think, in really three areas. The first is that there is a substantial co-investment going on in this program. And the idea of the company investment and the NASA investment working side by side is what has been happening under Space Act agreements. It's a little bit more difficult under FAR contracts to understand that unless one makes sure that those investments are allocated. And some of that is, as Brent was talking about, is whether or not the audit requirements are traditional under FAR or not. But there could be a lot of paperwork to manage how many, if you can imagine, if $1 comes in from NASA and $1 comes in from my company, and the person who's working then has to start parsing the time out between the two, that could become unwieldy in this kind of program. I think there are ways around that, but that's one of the concerns that I think is there. I think the other concerns that we have had, and which are also workable, is the idea that under this type of agreement, if there is a point to which where someone from NASA comes in and says, we think that you ought to make X change to the vehicle, that change then needs to be analyzed. Is it a safety-related concern, of which then I think we all are obligated to do it, or is it something that has something to do with the vehicle? The problem comes in this kind of arrangement in that in this fixed price, as we've heard, we don't have a lot of money. Where does the funding come to do that extra effort work? It's not clear for any of us. And funding is one question. The other is a question of time. Because we all have many dozens, if not hundreds of people working on these programs actively. If there's something that happens that stops the program, the paying of all those people under traditional cost-plus contracts, those people continue to get paid. You continue to bill the government for that work. Under a fixed-price contract, it becomes a lot more difficult to do that, and it isn't clear to us yet what happens in those scenarios. We're all concerned that significant delays in understanding the different processing times could hurt the programs and hurt the goals that we're trying to work with at NASA. It's not that these are things that can't be overcome, but it's an unusual set of circumstances, and I think that's why many people are looking at saying perhaps one more round of Space Act agreements leading to a FAR contract on the procurement phase was an approach that was being suggested and taken. But it's not the FAR contracts as they are. Anybody who does work with the government understands how to work with that. It's being able to take the two and blend the practices that we've used to this point in time under a new set of circumstances. And how does that happen in a very short period of time given very fixed amount of dollars?
I'll take a quick stab at it too. As far as how it would affect us or what we're concerned about in the contracting mechanism. So the things that Mark has pointed out about, we want to continue this successful model of fixed price, milestone-based contracting with the ability for us to put skin in the game where we think is appropriate. So that's a big concern. A typical FAR contract comes with a lot of cost accounting standards. And NASA's already said that they're going to try to exercise a FAR waiver so that it won't apply to this new contract of kind of Franken-FAR that they're working on. And so that obviously would be very burdensome. There's also cost and pricing data that has to be provided whenever you change or terminate or compete for a contract. That would, again, all these kinds of accounting things, they add, there's a couple impacts to SpaceX. One would be we have to hire a whole bunch more accountants, right, to comply with that level of accounting complexity. So there's a whole bunch of overhead that goes into hiring all these accountants to keep track of all this stuff. In addition, it's a big corporate culture change. I mean, our guys don't fill out time cards. If you go to Google, you won't see guys sitting at their desk filling out time cards, and we don't either. So we don't do Saturn training for all you guys in NASA. Yay, everybody! I apologize if you love doing your Saturn training, but we generally speaking, we don't have that kind of compliance burden. That saves us several man days, per person times the whole organization. That's a big administrative burden that we don't do right now. And what comes along with these clauses, a typical Space Act agreement might have about a dozen FAR clauses, and a FAR 12 contract might have say, 50 of these clauses. Well, a typical FAR 15, FAR 35 has got like 250 clauses. No one clause is that bad, but the problem is that you're legally on the hook to comply with it. So you have to have a compliance officer, you have to have a training program, and this is where all the Saturn stuff comes in, right? You got to do, you got to document that all that's been done. All this is an overhead burden that we don't currently have. So those are, but all this stuff can be addressed. We've gave this input to the Commercial Crew Program, and they are trying very hard to make sure that whatever strategy comes along, that they've addressed all these concerns. And we're certainly willing to work with the program to make sure that whatever it turns out to be, it's something we both can live with.
Jake, anything to add? Brent, did you have any comments?
No, I think Garrett and Mark said it pretty well. There's been a lot of talk about, is this FAR Part 12, you know, where are we potentially going if we do end up in a FAR-based instrument. We do have the flexibility to sort of create our own FAR part, as you might say, and pick and choose those clauses we want to have as part of the contract. So we are working very hard to do that. I mentioned earlier the cost accounting standards requirements, which was the majority of a lot of the comments have concerns about those. That's not actually a waiver. There's actually, the FAR appendix has an exemption, so you don't have to go get a waiver signed. You just, as long as you meet as long as you meet the requirements of that exemption, then you don't have to do cost accounting standards requirements. It's pretty straightforward. So, you know, this is really the type of input we need at NASA, so that, you know, we need to understand what clauses in the FAR do cause those problems, because one of our attributes, again, is to minimize overhead, to stay with milestone-based payments, you know, maximize IP rights for our partners, to ensure they have the flexibility to work effectively and quickly. So this has really been beneficial for us at NASA, because the one thing that we also have to be able to do under the instrument as we pick going forward, and that is to openly and fully engage with our partners on the requirements issues. The partners in CCDEV2 are constantly asking us about, do we meet the requirements? Do we meet the requirements? Because they all know, you know, eventually there will be a services contract, and you're going to have to meet the requirements. So they are trying to make decisions today on their design, and it's not, you know, there's some things that are very clear. Either you do or don't meet a requirement. There are some things that are gray, and you really need to assess the risk and understand whether, if they're partially meeting the requirement, is that acceptable to NASA. We're at the point in these designs, as we get done with CCDEV2 and push forward, most of our partners are at a preliminary design level, and they're ready to go to critical design, and we have to be able to fully engage on requirements. If we could do that in an SAA, and I know there's a lot of opinions about whether you can or can't, you know, an SAA would meet many of our attributes as long as we could fully engage in the requirements side. If we can't, then an SAA doesn't meet the attributes that we need, and we'll look for the most flexible FAR-based solution that meets the needs of our partners as well as NASA.
Very good. I'm going to modify a question here. It was about utility of this Sierra Nevada Dreamchaser, but it goes back to the fact that the shuttle had a mix of humans and cargo, which was good, but it was also bad, and bad in the sense that it increased the cost. What are your thoughts on maintaining such a mix as we go forward in commercial crew? Mark, you want to start? And I'll let the other panelists jump in.
Maintaining the mix of crew and cargo on the same vehicle, was that the question? Well, to go back and say that any of our vehicles are the shuttle is really a misnomer. They're completely different class vehicles, no more so than you would say a destroyer is an aircraft carrier. They're just different types of vehicles for different purposes. But the purpose we face now is not the need to bring and build major sections of the space station, but rather to provide transportation, safe transportation for people, and to maintain and bring down critical cargo. Absent any one of our vehicles going forward with one of these programs, there is no way to bring cargo back home right now. There's a Soyuz to bring people, but virtually no way to bring any substantive size cargo. So if we have a very functional, very large laboratory doing a lot of work, and we want to bring that that work back home beyond something that's a data stream, it becomes necessary to have a way to return critical cargo back. So I think our designs are meant to be flexible. In our Dreamchaser design, we have a reconfigurable cabin that could be all crew, it could be all cargo, it could be autonomous, it could be piloted, we call it optionally piloted, to allow for maximum flexibility. And because it's a composite design and we have the NRE already invested in the molds to build the design, we can actually have the same looking vehicle purposed for different ways, much like Boeing might repurpose a 747 to be all cargo, all crew, to be able to do servicing missions. We're doing the same kind of thing. And that, we think, opens up the maximum amount of flexibility to design and use a vehicle for the mission that's necessary. Because it's all done within the same outer shell, we're not adding extra costs, and the design for the vehicle was intended to do that from the very beginning. And the shuttle, in my view, did some very marvelous things, and while it perhaps never made the cost structures that everybody wanted it to go to, it was able to do some things, not only build the space station, but what my personal view, the most important thing it did was fix the Hubble telescope. I just heard this week that we got the 1 millionth image out of that telescope. And that's a pretty amazing thing. And I think it's something like 800,000 of those would not have happened had it not been for the humans involved with fixing that, the great astronauts who went out and did that work, and the ability for the shuttle to go do that. So there are other things in space that we need to look at, and a lot of people tend to be down on the shuttle program. We've learned a tremendous amount for it. It did what it was supposed to do. It was supposed to be the big trailer truck moving things. Right now, we don't need that trailer truck. We need a very functional SUV to take people and cargo back and forth as necessary.
Well, we're taking a very similar approach to what Mark just said, and so we tend to have a cargo Dragon as well as a crew Dragon, and it's true that we're going to separate out the cargo and the crew, and it's true that it's going to be more like a SUV than a giant pickup truck that can bring up elements of the space station. But we're starting with the cargo part very, very soon. Again, set your calendar, November 30th. I'll say it again. You'll see a Dragon go up and bring stuff home from the space station. And so we're doing that, but at the same time, we're trying to keep as much commonality as possible between the booster would be identical, and then the Dragon spacecraft that delivers cargo is going to be as similar as possible to the Dragon that carries crew. The only difference is one has seats in the one for the cargo. But otherwise, for manufacturing purposes, it'd be the same. The other great thing about that is every time we launch a cargo Dragon, starting last December and continuing in November of this year, we get data that is applicable to the manned vehicle. So we get basically a free test flight every time we launch cargo to the space station. So and also we get these capsules back. We can use them for testing. There's a tremendous amount of utility we get out of having commonality between the vehicles, and we intend to keep doing that.
Brent, I hadn't checked the requirements recently, but do we still require cargo capabilities in our draft CCP requirements?
There is, in the last draft, there was some limited cargo capability that was asked for by the space station program.
Yeah, station program wants to bring stuff up and
It's
down.
it's about 100 kilograms to go with the crew.
Here's an interesting question. I'm going to add my own little introduction, but I mean the moving things to the commercial space sector, by the time that reaches the public, all they hear is the space program's been canceled, right? How many people have walked up to you saying, why are they canceling NASA, right? So this question says, well, it's been a major responsibility of NASA to reach out to the public through our media affairs, our educational outreach, and so on. With the commercial side of space expanding, will this become a shared responsibility? And perhaps how do we get this message that space is not just for the government anymore, that it's still a viable, if not even more viable, program with the commercial element? Let me open that up to anyone.
Well, as far as, is the question more towards advertising to the public to sell the concept
Yeah,
of
should we be
space?
working together on this, and how do we
Yeah.
do that?
Well, I think ultimately, we're going to see a lot more robotic kind of missions to deep space for exploration, whether you're going to Mars or the asteroids or lunar type exploration. So I think there's going to be a marriage between the manned kind of activities where you're engaging humans in space, working in space, and also the robotic kind of activities there. So that would be my put.
You know, Dennis, it's always really been a joint responsibility between industry and the government to not only communicate to Congress and the executive branch, but also to communicate to the public. I mean, you see, obviously you see commercials on TV for aerospace companies, and they're doing that for some reasons, but it does, those kinds of things do help raise the awareness of the public as to what the benefits of space are and why it's important to invest their tax dollars into space exploration. I think the challenge we have with the public is, since we call this program Commercial Crew, I think the challenge we have is explaining why it is also important to invest in a program that's called commercial. And that's something I think it's not only a hurdle with the public, but I think it's is also a hurdle with Congress, because there's a sense that we're just giving the taxpayers' money away and we're not getting anything back for it. It's all to the benefit of the company. Well, I can tell you that our program at NASA has two purposes, right? We want to develop a capability so that we can fly NASA astronauts to the space station on a U.S. vehicle. The other purpose of the program is to enable a capability that allows a commercial market to develop. So we have those two fundamental purposes. And when the taxpayer gives me these questions like, why are you just giving money to the commercial, to industry so they can make a profit? I tell them in 2015 or in the middle of the decade, if we achieve a system that can go to low Earth orbit, but it can't take our astronauts to the space station, the country will look at the program, and NASA will look at the program, meaning myself and Ed, and say, you are a failure. You know, we have to be able to provide that capability that's the reason we are investing your tax dollars into this program. The other benefit that we are ensuring that we maintain is this development of this other market. So as more flights come online and we're flying more than a few times a year, the cost goes down. So that's the message that it's hard to get across sometimes, because there's just this perception out there. And other than continuing to preach, and it's easy to talk to we're kind of preaching to the choir, you all understand the benefits, but we are facing a huge perception problem, I believe, in some parts of the government as well as some parts of the country.
I agree with Brent. I think things started badly or often difficult to reclaim. And I think all of us collectively probably did not initiate this program with the same kind of forethought that we now realize we probably needed to. We need to be honest with that, and we need to be self-critical. We did not go out there and create a positive message early on well enough so that the message was heard. That doesn't mean it can't be done or it's a failure. And I have to say that there is a huge pent-up interest in what we're doing. I can only refer back to my own experience when I was down at the shuttle. I probably did 30 or 40 interviews from countries around the world. I never knew how I sounded in Portuguese and in Japanese, and it's sort of funny when you hear it translated. But what that told me is I saw how many people were interested in this, is that what we need to do is to stop and recognize that maybe we didn't do as good a job collectively as an industry and as an industry partnership with NASA as we needed to, and make those changes. And how do you do that? I think there's three simple ways. One is we celebrate the successes. There have been a lot. Flying is a really big thing, and as we all get to fly, we should make big announcements around that. We should have a recognition that this is part of the American fabric, and celebrate the successes along the way more than we have been. I think the second thing that we're doing is to reaching out to the next generation of students. We have 2 universities in our program. We spent a lot of time recently going out and trying to pass the word out of why those the people coming up in their teens and their 20s ought to be interested in this. And it's starting to really get out there, and I think it's a really positive thing. And I think the third thing is that we recognize that we have to sit down with NASA and work out a plan for communication so that it's not just responsive or reactive, but we're actually out planning, and we really haven't done that. We've planned the technical path, and we've planned the financial path to a certain degree, and we've planned the milestones, but we have not equally planned the communication path. And I think that ought to be a major element of this next phase of the program, that there be an identified responsibility to all the companies to work with NASA to communicate what we're doing, not as something that's an anecdote, but something that's a stated part of the program.
Okay, very good. Garrett, did you want to add anything?
Just really quickly, just to say, yeah, I do agree that we could work better together on a more cohesive communications program. We're doing a lot of stuff on our own at SpaceX. We do broadcast all of our launches live over the internet. We have a Twitter account. We're doing all those things. We got a bunch of people working on that stuff. What's our Twitter handle? SpaceXer, right? At SpaceXer. So you follow us on Twitter. We're doing all that, but none of that is really going to be anywhere near as powerful as just showing on television the first time somebody in one of our vehicles docks and enters a space station. And so the best way we could reach out and get the message out is by doing it. And I hopefully that we're not far away from that.
Great, thank you. A lot of you asked questions about markets, and I think we're going to push those off to the, there'll be a panel later today on orbital markets, but I wanted to end with a quick question, quick answers from everybody. So Russia announced that the space station will be plunged into the ocean in 2020. Do you agree? Quick. Yeah, this is the final round. Quick.
I think
Yes or no? Yes.
No, I don't think so.
All right, good.
No.
Next.
I'll go with no. Certainly
All
hope
right,
not.
we got 2 no's. All right.
No.
All right, 3.
I don't think so, no.
All right, now that begs the question, so what are we going to do about it? But we'll leave that to another day. Anyway, I want to thank you all. Great job to the panel. Please give them a big hand. From launch to lunch. Oof, sorry.
All right.
Dennis, it's safe.
So lunch is right down the hallway to the exhibitor hall where you were before, and take a right. And the sooner you can get there, the better, because the lunch talk will be starting in about 30 minutes, and we want you to have time to get your food and eat it. Thanks.
Yeah, well, we have showed a ability to plan train wrecks in terms of our dependence on them. It's astonishingly broad. I mean, 6 years' notice. Yeah.